Alright, so welcome back again. My name is Jesse, and in this wonderful and exciting tutorial, we're trying to do an end-to-end machine learning data science project. So the problem at hand for today is that you'll be trying to see how to use machine learning to be able to classify a GitHub issue. So GitHub issues, as you already know, if I go back to the official Streamlit app, it's having this particular section here. In every repository, we have issues, right? So in this particular issue, people are sending for the issues there of what they have, and all of these particular issues have a particular tag or a particular label. So we're trying to see how to use machine learning to automatically assign these labels, right? Instead of the human being doing it, we want to use machine learning to help us with that. So these labels can be found here. As you can see, these are all the various labels. You can create your own custom labels, as you already know, and there are also some official labels there already. So it can be bug, it can be, let's say, cloud, confirmed, customization, data frame, and the rest. These labels too can also be found here, right? So let's see, if I check it out, you can see that it's going to list all the various labels that you have on GitHub. I think Streamlit has a lot of labels. Wow. Okay, so we have API, we have arrow, bug, cache, charts, and the rest. So what we want to do is I want to train an ML model, right, to be able to assign these particular labels to issues, right? That is the basic understanding behind it. So there are a lot of projects and there are a lot of apps on GitHub that allows you to be able to do that, but we're trying to see how to do it from scratch. Okay, so let's see what we're doing. So there's it. So we have some test, which is an issue, and then we'll be applying an ML estimator or algorithm on it to assign the right label to that particular issue found. Apologies for the noise maybe hearing behind. So this is going to be our workflow. So we're going to fetch our data set. So the data, there is something they call GitHub archive. Let me show you here. There's something they call GitHub archive, right, which is a service that archives all of GitHub, right? Every publicly available dataset is archived here. So there is also BigQuery that you can actually make some queries on using Google BigQuery, right? This is it, right? You can actually make some queries to be go query and fetch all of these particular datasets, right, as you want. But you will not be going through that step. That is another thing. People have already done the work for us, right? So we will be first of all taking back again. So we'll be fetching the dataset, right? So these are the two main ways you can fetch the datasets from GitHub archive here or from Google BigQuery, right? And then you make some query to that particular archive and fetch that data specifically. That is going to be the first step. Then after fetching the data, you're going to doing some data preparation, data cleaning. Then after you have prepared the data set, you are going to build our model. You may interpret, you may evaluate. Then after that, you're going to serialize our model and deploy the model. So be using Streamlit to deploy this model. You can also use Fast API, you can use Flask, and then the resulting data that you are getting, you are going to be storing it inside the SQL model. So let's see what we build at the end. So by the end of this tutorial, this is what we'll be building, something very simple, which is a very simple GitHub issue classifier app built with Streamlit. Streamlit makes your work easy. So if I come back here, let's pick an issue from Streamlit. So I'll go back to Streamlit issues. I'm going to pick any issue. So let's see, this is a bug, right? While trying the data set, something. So I want to copy this one. I want to see whether we'll be able to get the issue, right? The particular label. So this is a model that is trained on a different data set, but let's hope we're able to get something. So if I click on it, predict, it's going to run this particular result and give us our prediction. So let's see what it's doing for us. And as you can see, but when I pasted this here, this is a bug. As you can see, this is the issue found here was what was a bug, a bug, right? And based on our machine learning model that I have trained, the prediction was that it was this original test and this is a bug, and this is the percentage, right? As you can see the percentage of the different classes. Very simple. So bug is very high, and apart from that, we are using Streamlit metrics to be able to give us this wonderful result here. So you see that the bug is 89%, as you can see it here, and then the enhancement, and then these are the various prediction probabilities. Very nice. So that is a simple app you'll be building, and then the resulting result, whatever is pasted here, will be stored back. If I go back to the monitor, we'll be using SQL model, which is a very nice package, to see the result. See that all of those things that have been made is here. Very nice. So let's see how to build this wonderful app from scratch. So we'll be trying to see how to fit the data, then move on to throughout this process. So apologies for how it's going to be, and apologies for the noise you may be hearing behind. So credit, so the data set that we are going to be using is already available. So this particular package ticket tagger already does that thing on GitHub already, so you can actually fetch it out on GitHub. So we'll be fetching that data set from here. So I'll go back to this particular website here, which is here, right? That is where the data set is, right? Already done already for us. That is a wonderful work. So these people, Raphael's, Young, Song, Oscar, Chaparro, Tim, Mosa, David, all of them have done the work already. So we are trying to go through their project to see how it is, right? Okay, so we're going to import our EDA packages, and I'm going to import our machine learning packages to help us with our task. So let's download this particular data set here. So we're using wget to get fetch this data set. So I'll just go back to my workspace. Let's go back again. We're doing everything from here. So this is going to be the first step. So data collection. Going to be fetching the data. So we're using wget, so wget, right? Then I'm going to move into that particular stuff. So this is going to be used to fetch the data set for us. So let's fetch it. So the bank here, I don't know whether you can see it, or apologies for that. The bank here means that it's a shell command, so it's going to download this particular data set, and we're trying to see how to analyze it. Perfect. So that is it. Now the data set is already here, as you can see. So I'm going to move this data set into my data folder, right? So let's move it there. So the data set has already been moved into my data folder, right? Very nice. So let's start writing some code. I don't know whether you can see it, or I hope everybody can see it very well. Okay, so we'll be doing it very fast so that we're able to save time. So let's check it out. So you have fetched the data set. If I go back to bank ALS, you can see that we have our data set here, right? Perfect. So we want to be able to clean this particular data set. So let's use pandas to load this data set. I'm going to load the data set. dfpd.read _csv. This is a TST file, but we will be reading it with pandas, so CSV. So let's check it out. This is not correct. There's no space here, so the file was not found. Now it's going to find a file. So let's check it out. So sometimes when you fetch a data set like this, right, you may be thinking, wow, whoa, it was good, right? But you can see that it is not in the best format. This format here is in the format of fast test, right? Fast test, you know, fast test. Yeah, that is why it is in this particular option, but we want to convert this one into a CSV format. So how do we do that? I'm just going to move back here, and I'm going to specify the header. Let's go to none, and then let's run it again. Perfect. So we can't, because of how the structure of the data set is, we cannot just use tab. You can't use tab, you can't use CSV to read it, right? It's a TST file. So how do you fix this particular issue? So we're trying to see how to clean this data set again. So we already see that we have this particular one here, this thing here, right? So we want to split it per this particular label. So this is the label. So everywhere that is having these things, that's what we're splitting it on. So let's do some test cleaning. So based on the test cleaning, we want to be able to split the data set, right? We want to not split, but we want to extract the labels from the test. You may be thinking it is easy, right? But it is not an easy task. So that's what we're trying to do for the test cleaning aspect. So we want to extract these particular labels, right, from the test. So the labels, as you already know, is that all of them in a format of, they were originally in fast test format, right? That explains this thing. So we want to be able to get this one out. So label, and then the particular classification or particular tag. So enhancement, and then the rest. So we have enhancement, we have bag, we have question. So these are the three main ones based on the data set, right? Perfect. So let's see how to fetch these ones out. So I'll just go back again. Then we have my data set here, as you can see. So I want to fetch the first one. So it's going to fetch the entire stuff, and then I want to split this one also. Dot string dot split. I just split them per this particular one. So this is going to be my regular expression. So we will use regular expression to help us with that. So R, right, and I'll paste it here, right? Perfect. That's going to be the first one. So if I go with this, it's going to only fetch these ones for us, right? Perfect. So let's do it in this way. So I'm just going to put inside a bracket, right? So that's going to be the first one, or another one, right? And then the next one is going to be, so we have 3, right? So either it's going to fetch this or fetch this. So let's change this one from enhancement to bag. Then this one is going to be from enhancement to question, because there are 3 different labels there. So if I run it like this, and I have to make sure that if I'm splitting, I must specify that it's supposed to expand as true. So expand is called true, right? So if I run it like that, now it's going to split the entire stuff for us and give us our result. Perfect. So as you can see, so it has splitted them. So 0, 1, 2, 3, 4, right? So from what you are seeing, you are realizing that number 4 here is the description, right? This particular description that we get when you go back here, this particular description here, and this entire description here, right? And then number 1, 2, and 3 are the labels, right? As you can see, this enhancement, this is label, and then the other one is going to be question. So let's fix them out. So I'm just going to go back again. I'm going to call this one as df new, right? I'll come back again and get it back to the normal option. I'm storing this one into a new variable, the df new, and then as you can see, if I go back again, and then we know that number 4 dot head, we know that number 4 is the description, right? So number 4 is always going to be the description, and then number 1 is going to be for enhancement. So we want to get all the enhancement together as 1, and then the rest. So let's call this one as enhancement df, right? So let me show you what I mean. So I'll come back again. It's going to be my df new, right? If I go back again to number 1, right? If I fetch this one, I was only going to get the enhancement for us, and then if I go back again, so this is going to be enhancement. So this is going to be label and enhancement, right? So this one is only label enhancement. All the nouns are going to be dropped, right? So if I go back here, so df new, so this is only going to give us only rows with enhancement for the first one. Perfect. And I want to drop 2 and 3 and pick only 4 and then 1. So in that case, it's going to be pick 1 and then 4. If I pick 1 and 4, we only have 4 enhancements. So let's create this one to enhancement df, right? Perfect. So we do the same thing for the rest. So I'll copy this one and repeat it for the other 2 classes. So this is for bag. So bag is going to be number 2, because based on how we set it, bag was number 2 here. The bag is going to be 2, and then this is going to be number 2, right? So let's call this one as bag, B-U-G. I don't know how to pronounce it, bog or bag. And this is going to be for question, right? Question df. So label here is going to be question, right? So this question is number 3, and then this must be changed to number 3. Perfect. So if I go back and I check for the bag df dot head, we're going to see that we only have for bog, right, or bag, right? American English. If I go back to the question df dot head, we only have 4 questions, right? As you can see, right? Label questions. So we have been able to split them separately, right? Perfect. This is still part of the clean. Now let's make it work. So I'm just going to assign labels to all of them. So let's assign labels. So df dot columns. This one is going to give us 1 and 4. But 1 and 4 now, I'm going to assign a label of target or the label, and then let's call this one as my description. We can call this one as the label. Anyhow you want it to be, let's call that label. So we have the label and then the description, right? So this for the other one, and then this is going to be bag df with columns, the same thing. So I'll repeat this one to be able to assign the right column names to it. So question df dot columns, right? Perfect. Now we have assigned it in a better format. So let's concatenate them together. So I'm going to add all of them together. So concat data frames to get one data frame, which in this case is going to be this option. So let's go to df, right? Then pd.concat. I'm going to pass in my column. So enhance df, we have bag df, and we have question df, right? Perfect. So I'm going to concatenate them together. Now if I check it out, we have them perfectly well, right? You have splitted them in a nice format. So let's check for the shape. So df.shape, and it's supposed to be about 3000, right? Perfect. Okay, so this is nice, this is good, but this is not the best format. This is in fastest format, so I can save this one as CSV so that somebody can use it for. So df. Let's save dataset. So df.to CSV. Then now I can save this one as, let's give it the same name that we had. So the name we had here was right. So I'm going to change it from this one, copy this one, and then I'm going to change it here to a different name, right? Perfect. Dataset labels, top 30k real. I'm going to change this one from GitHub issue dataset, right? Something like that. Label top 20. Then this is going to be CSV. Perfect, right? Now we are converting this entire stuff into CSV so that in the future you can have this dataset and use it for yourself. Okay, we are done with the first task of fetching the data and then preparing it. Now we want to still be able to clean it well to make it easy for our task, because we cannot be predicting this option. This is bad. Okay, so let's clean it. So I'm going to be cleaning. So if I go back and I check it out here, if I check it out, you see we want to be able to clean this one. So I want to strip off all the labels. So df label, right? And I want to strip off the, or replace rather, let's replace. I want to replace everything that is starting with this. So I want to split this label, right, with an empty space. If I go back with this and I click on this, now it's that has replaced everything from it, right? So there's none of these things are there. So let's equate this one back. Perfect. So if I go back again and check it out, now this is better. Perfect. Okay, so we can actually also save this one too. Let's save it. So it is the best one to save, right? So let's save this one. Let's take out the real. Yep. Okay. Perfect. So let's do some simple class distribution analysis. We want to be able to know whether the dataset is balanced or not, right? In order to build a somehow robust dataset or analysis. So this is going to be class distribution analysis, and in that case, I can just use Seaborn to do it, or just go with df. I'll pick the column, it's a label column. Right, dot value count. So we see this particular percentage, and we can actually plot this one. So let's plot it with Seaborn. So SNS dot count plot. I'll pass in my column, which is my label column, and I'll pass in the data set. So data is going to be my df. So if you check this one out, we see that we can see from our data set that the enhancement is okay, bag is also a lot, and then questions is not as small, right? So this is like almost imbalanced, but we will keep it like that, right? Okay, now let's move on from here to build our model. So first of all, in order for us to build our model, we need to be able to clean and pre-process our data before we start applying it to our model. So let's do some simple test cleaning. So we'll be using a very nice package called NeatText. So this is going to be test cleaning, right? Using NeatText, you can use any package, but I prefer to use NeatText because it's simple, right? So in case you don't have NeatText, I just install it with pip install NeatText, right, on your system. So that's the package you'll be using to do our test cleaning. So if I go back and I pick one of them, so let's say ilog 0, you can see that we have dot description. You can see that we have all of these things here. So some of them need to be cleaned. Here we have some hashtags, we have some stop words. We want to be able to clean some of them. But one of the things I've noticed that since this is mostly issues, right, I prefer to keep as much details within it as much as possible, right? I want to take out the stop words, but I want to maintain some of the special characters, right? Because some of the special characters can be very useful in this particular case, because this is code, right? So in that case, I'll take off the stop words, reduce everything to lowercase, and then maintain the other characters. So let's see how to do that. So using NeatText, so import NeatText dot functions as NFS, right? And then, as you already know, with NeatText we have a lot of features we can do with it. So let's use NeatText to remove the stop words. So let's go with my df. Then we are picking from the description column, description, right? And I want to use apply. So lambda x, right? Then I'm going to pass it into my NeatText function. So I want to remove all stop words, right? So s. So let's convert this particular s, so string s to lowercase. Now we get everything back to lowercase, right? To lower. Automatically it's going to do that, but you want to get everything back to lowercase. So my df description clean. Right. That means that these are one that we are cleaning. So let's apply it. We're going to take some time to remove all the stop words from it. Voila, so we have gotten our stop words removed. So I go back in and I check the same thing that we had here to see whether it worked. So we are picking the description clean. I'm going to compare it with the previous one, and you can see that the stop words have been removed, right? So the method has been taken off, right? And some of these stop words are taken off. R is gone. You can also remove some of the punctuations to make it easy if you want. So that one depends upon you to make it more robust. So let's see whether I can move some of the punctuations. So I'll come back again, copy this one, and let's remove some of the punctuations. But what I was saying, that if removing some of the punctuations may affect the work, yeah, so you can leave it or you can keep it like that. So let's remove some of the punctuations. So clean, because most of the time, this was, for example, something like that, removing this one is going to affect it, right? Because this is vital information. I know that there's a bug with 1.22, so it is vital information. So that's why I prefer not to remove some of the special characters. But it's up to you anyway. Okay, let's move on from here and let's move on to building our model. So be using, right, to build our model using a pipeline approach. So pipeline approach. So we're using pipeline because pipelines, when you're working with text classification, always use pipelines, right? It always makes your work easy. Always use pipelines. So let's use pipelines. So I'm going to create my first pipeline. So the pipeline is going to consist of my data to data. Let me show you that image to help you understand. Okay, so this is one of the images from some time ago. So in case you are building a pipeline, right? So most of the time, NLP pipeline mostly consists of these two different stages, right? We have the transformer stage and we have the estimator stage. So a transformer is any function that takes in data, fit it, and transform that data into a different format of data or a feature, right? So that is called the data to data stage. So in this case, you'll be using TF-ID vectorizer or count vectorizer. All the scalars, all the vectorizers, all the structures are forms of transformer functions, right? So tokenizer, stop word remover, count vectorizer, IDF, they are all transformers, right? Perfect. That is going to take in data and transform that data to another format of data. We also have estimator. So estimator is a function that takes data as input, feed the data, and then produce a model. So you pass in data into that particular function, then produce a model. So all the ML algorithms that you know are all estimated, right? So logistic regression, naive Bayes, KNN, all of them are estimated. So let's see how to build a simple pipeline. So it's going to consist of our transformer and then our estimator. So let's build it. I'm going to call that pipeline. Let's build a naive Bayes model because naive Bayes is very useful. I can also build a logistic regression. I'm going to make my pipeline. So pipeline pipeline always consists of steps, right? And then steps are going to be in this particular format. So we're going to have my count vectorizer, which is going to be my transformer. You can also use tf-idf. So count vectorizer, and I'm going to call that my count vectorizer. So count vectorizer has already been imported from above here. So we imported them at the beginning of our work. So we have our pipeline, and then we have our estimators here, right? So we are using count vectorizer. You can also use tf-idf if you want. All depends upon you. Perfect. And then from there, I'm just going to create another one, which is going to be, this is going to be my estimator or my ML algorithm. So in this case, let's use naive Bayes. So let's go with naive Bayes. So we are using multinomial, which is very useful because trying to build independent features. That's going to be the first one. You can also build another one for, let's say, logistic regression. So I'll copy this entire stuff here, and I'll build one for logistic regression. You can also build decision tree if you want, as you wish. It depends upon you. So let's build one for logistic regression, and I'll change this one to LR, and then let's build one for logistic regression. And we can also build another one for decision tree. So one thing about decision tree that if the data set is imbalanced, you're able to work about it. So DT, then this is going to be decision tree classifier. So sometimes when you are building a model, you may also need to build a baseline model, right? So let's build our baseline model here. So let's call this one as my base model. So this is going to be dummy classifier model. So let's call that dummy. That becomes too big. Apologies for that. So in case you have any question or contribution, you can put inside the comment section below. Okay. So let's go back again and see. So this is going to be decision tree. This is going to be dummy, right? We are building a dummy classifier to build our base model. So this is going to be dummy classifier, right? So this is going to be my base. So let's run it. So it's giving us an error because we made a mistake somewhere. So let's fix them out. So count vectorizer is not defined. So let's see why. Okay, I think there was a typo, right? Yeah, there's a typo here. Perfect. So we have built out. So let's check on our base. This is going to be our base model, right? Or base pipeline, which is going to be this particular. I want to see the base model that we need, the base model for the accuracy, where we are pitching it against, right? So first of all, before we do that, let's split our data set. So I'm going to have my data set here. We have my S feature, as we already do. Then df.description. So I think the description clean, right? Because it's a clean one, and then my Y labels. So df is going to be my label. Right, perfect. So we have these two here, and we want to split the data set. So to split it, this is going to be for my features, and then labels, right? We want to be able to split our data set, so we want to split it. So we're splitting it to this, so this is going to be this option. I think train test split, so S-train, I'll copy and paste it to save us time. Perfect. So this is what we are doing. So we are splitting them on 30, 70, right? Perfect. On a random state of 42. Perfect. Now let's build our base model. So to build our base model, we're using a dummy classifier. So it's going to be my base, so pipe base, right? Then I'm going to go with dot fit. I want to fit that one into my S train, and then my Y train. Right, so it's going to take some time for it to run. This is just going to build. This is not learning anything. This is just giving us the base model, what we are thinking the accuracy of the model is going to be. Then I can just check for the accuracy before we build the other model. So we did not learn anything. This is just trying to give us the base, right? So let's check it out. So it's going to be this option. in case you have any question or contribution, you can also let us know in the comment section below. So this place, I'm going to go with the score. Right, then let's go with test. Let's check it out. So this is base, right? So base means that it's not learning anything. So I want to get, so this is going to be our accuracy, the base accuracy. So any of the pipelines you are building, the accuracy of the model should be around 50, right? That is the basic understanding. So let's move on from here and let's build our actual models. So let's build the first one. So this is going to be my pipe naive base. Then I'm going to do the same thing, dot fit. So we have S train, Y train. So let me take this one off. And I do the same thing for the other one. So you just let's build just two. So I'll build for naive base and I'll build for decision tree. Right, and I'll build for the logistic regression. So it will take some time. So this is going to be for logistic regression. Right, so let's check it out. So we can actually time it to see the time it takes to do the training. Right, so in that case, we'll be just using time. But I don't want to do that. Let's move on to save us time. Perfect, so that's finished, right? So I just trained for one for the naive base and then for the decision tree, right? So this is going to be your assignment. So let's see how to get the accuracy of this particular model we have done. So simply you can just do it like this option. So pipe nb.score. Then I'm going to just check it against the test option to get the score of this, right? So as we are saying, we already have our dummy classifier telling us that's supposed to be 50. Wow, now it is 65, right? So 65 is better. This one was 50, right? So that means that we are still on track, but we have to also evaluate this particular model. So let's evaluate it. So I'm going to use the Y predict to get the values, and then I'm going to use classification report to give us more details about that. So let's go back again and then let's check the classification report. Right, so it's going to be my print and classification report. Then I'm going to pass in my Y test, right, and then a Y predict. Perfect. So based on this, based on what's the most important thing now, this is accuracy 0.6, which was the same thing that we saw here, right? 0.6 round up, and you are checking the F1 score. So the higher the F1 score, the better. So the F1 score is better, right? The higher the better. In all of these cases, the higher the better, right? So the precision is 75, the 59, 39. So this is very good, but remember that the question was very low from our diagram here. The amount of data points belonging to the question class was very low. That explains why, even based on the classification reports, we can see that the precision for our question is low, right? And then even the F1 score is also very low, meaning that we need more data to augment this particular data to make it better, right? But this is okay, we can still work on it. So now let's move on from here to work on the other ones. So I'm going to do the same thing here. So let's check for the accuracy. So pipe dt.score. So this is going to be my S test, and then my Y test. I want to see which of these ones are good. So this is for the accuracy here. Which is better? So the 66 is better than the 658, right? But let's check this one. I'll copy this, to help us understand it better. So we'll go back again. So I'm going to do this one for the decision tree, then I'll apply it here to see the result. So let's check it out and see. So let's check the F1 score. Okay, this is 67. But looking at this, the F1 score for this is better, right? The question for the decision tree. As I said, most of the time when you're working with imbalanced dataset, decision trees and random forest always do better than the rest, right? So let's see this particular model. This is going to be an assignment. Let's see these particular models we have and use it in the next stage of trying to build our model. So we have finished with all of these stages. We can also move on to interpret it, but let's leave it here for some time for now, and then let's move on to build this our wonderful app. So let's save our model right that you have built. So be serializing it, serialization. So be using job lib to help us save our model. So this is going to be an assignment for you, right? So we are using job lib to help us with that. So we import job lib. You can also use pickle. You can use array. You can use honest, right? Anyhow you want to be. But let's use job lib to help us with that. So I'll copy and paste the code to save us time. So we are using job lib. So I'm just going to open a file, right? And most of the time, this is how I save it. So if it's a pipeline, we just specify the components of the pipeline, and we just specify what it does, and then the time or the date that the model was created, right? That is how I do it. And I'm going to dump it back. So see this one here, and then I'm going to do the same thing for the decision tree. So there's a decision tree pipeline consisting of decision tree and then converterizer, then what it does, right? And then the date. So in case you are watching from the future, this was the date. Okay, so we are done with this. We are done with most of them. So we'll be using the decision tree classifier to help us with that task. But you can use the naive base because it's faster, right? So let's move on from here to the next stage of trying to build our app, right? So we're trying to build an app. So let's go back again to our workspace. And then let's go back and do some stuff. Okay, so we have seen how to build a simple machine learning model and pipeline to be able to do some simple prediction. So before we move on to the next stage of building the app, I'll be pausing here. Then in the next session, we will try and build the app from scratch. But let's try our models out, right? So this is going to be trying to make individual predictions, right? To see which of them is good. So predictions. So I'm going to have making some simple individual predictions. So let's make some predictions. I'm just going to go back again. Let's go back to the Streamlit issues. Let's pick any issue, random issue, which it has not seen before. Then we're trying to see whether we'll be able to make some predictions on it. Right, so let's go back here. Right, perfect. So I'm going to pick this one is a bug. I'm picking this one. Everybody knows that this is a bug, right? Oh, see me. So we know that this is a bug. So I'll copy this here. We know that this is a bug. I'll copy this one and then I'll come back and so this is going to be example 1. We know that this is what a bug, right? So let's put it here. Example 1, we know the actual is going to be a bug, right? We also need to get one for, let's say, enhancement or something. So example 2, we know that example 2 is going to be for enhancement, right? Or any of them, anyhow you want it to be. So let's pick one. I don't know whether there is an enhancement. There's an enhancement here. Yeah, let's pick this one. I'll copy this one and then now use it. We're trying to use these things we have not seen before. These things is totally off. Okay, so let's make our predictions. Right, so we'll be testing on the first one. We are using the naive base pipeline. Naive base, so it's going to be my pipe. Naive base dot predict. The advantage of using a pipeline is that both the count vectorizer or the transformer together with the estimator are together in the pipeline. Now passing here, example 1, right? So let's see the prediction. Wow, this is an enhancement. The model told us that this was enhancement. I have no idea why this is enhancement. Okay, so let's try it again with example number 2. This is supposed to be a bug, right? So perfect. So example number 2 was correct, right? But example number 1 was wrong. It told us that it was enhancement. I have no idea. Maybe sometimes it's possible for something to be an enhancement. This is a bug, but it's saying it's an enhancement. Anyway, we'll keep it like that. So let's try it for the decision tree. So this is going to be for decision tree DT. So DT, let's check it out. Wow, so the decision tree was able to be smarter than the naive Bayes. So the decision tree said that this one is a bag, as you already know that this is a bag, right? And then let's try it for example 2. So that means that the decision tree is more smarter. So let's go with this 2. If you tell that that is enhancement, then you are going with the decision tree, right? Because it is better than that. We can also check for the prediction probability. So let's check for the probability for this one. The reason why this one gives us that wrong prediction. So I can just copy this one here and check for the prediction probability. So predict proba. Let's check it out. So this, to know the classes, can just come back again and then let's print naive Bayes. Say pipe naive Bayes dot classes pipeline. Now you know what it is. So bag enhancement, see that this is very low, 60 something. Yeah, but let's try the same thing on for the decision tree for that one and see the difference, which was here. I hope you're enjoying it. I hope it's not boring you out. So DT, right? So let's check it out. So if you check it out, see that this one is 100%, right? So the decision tree is better than, in our studies, it's better than the naive Bayes, right? But the naive Bayes is faster than the decision tree. So let's see how to use this one in the next session and how to build our model. So to recap, what we did was that we had a problem that we wanted to solve. So the problem was that we had issues, right, in the format of text, and then we build a machine learning model to be able to assign the appropriate labels for the issues that we have, right? So we're trying to fix this particular issue of, instead of a human being doing this, now the machine learning model will be the one assigning this particular one. You can actually train it to use the two of the models to give double tasks, right? So that is something we can also do. So thank you for watching, and then see you in the next session. Stay blessed. And then credits to these wonderful people that help us make the dataset easy for us. To B, Yang Song, Oscar, Tim Moser, David Steiger, Raphael Callis, right? These are the powerful people that did the work to make it easy for us. So thank you for watching. See you in the next session. Stay blessed. Bye.